right, so we're going to go over some of the homework questions on 7.5. 7.5, the first question that we had was number 9, so we'll do number 9. Number 9. Number 9, we have 2x squared plus 1 dx, and yes, this is a trick question because x squared plus 1, you cannot separate, right? There's no way to separate that. So this basically actually is 1 over 1 plus x squared dx, and this is nothing more than arc tangent. So your answer is going to be arc tangent of x plus c. Okay? So there is no separating this. Okay. Number 13. Number 13 is a little interesting. I want to go over this one because something interesting happens here. Number 13. Number 13, we have 8x minus 7 and 2x squared minus x minus 3 d of x. So you have to go ahead and you're going to have to put this into two different terms here, right?
Right.
So that's going to be 2, 1, 3, 1, x plus negative. So I have negative here plus there. So this is going to be separable as 2x minus 3 over something and x plus 1 over something d of x. So we do not know what these two are, and as a matter of fact, that's what we're going to solve for. Okay. So if we do that, we get over here, if I combine this, I'm going to get 2x minus 3, x plus 1, ax plus 1 plus b, 2x minus 3 dx. So this guy here, I'm going to get ax plus a, 2bx minus 3b. And as we did yesterday, we're going to combine the x terms. A plus 2bx. I'm going to get a minus 3b. And this has to be equal to 8x minus 7. 8x minus 7. So as you can see, if you match them up, a plus 2b has to be 8. A minus 3b has to be negative 7. So let's solve that. A plus 2b is equal to 8. A minus 3b is equal to negative 7. So I subtract out 2 minus 3b, so it becomes 5b. 8 minus 7 is 15. b is equal to 3. If I put that in here, I get 3. A is equal, b is equal to 3. So I put it in here, I get what? A minus 9 is equal to minus 7. So A must be equal to 2. Yeah, is equal to 2. So basically, this guy here becomes 2x minus 3, 3x plus 1 dx. Now the second term is actually not too bad. This guy here is nothing more than 3 times natural log of x plus 1. The question is, what is the antiderivative of this guy? Okay, this guy here. The antiderivative of that guy really ends up being natural log of 2x minus 3. Well, Mr. Brown, what happened to the 2? Okay. What happens to the 2 is that if you take the derivative of this, what do I get? If I take the derivative of this, what do I get? 2. I get 1 over 2x minus 3, but then I have to do the chain law. So the chain law, so if I get that, then I have to multiply that by 2, which ends up being this. So that's where that 2 goes away. So in other words, this just becomes natural log of 2x minus 3 plus 3 natural log of x plus 1 plus c. Okay? So that 2 disappearing here. And the reason why that happens is because you have a 2 in front of the x. Okay? So I wanted to go over that so that you understand that. Okay? A little tricky there. Okay, so then we'll do 21.
I have to pay attention to this.
21. Okay, for 21 I have x squared plus x plus 1, x squared minus x, dx. Is x squared minus 1 or is x squared minus x? X squared minus x, so write that. So if I do the division, x squared plus x plus 1, x squared minus x, I'm going to get 1, x squared minus x. If I subtract that out, I get 2x plus 1. So this guy here is going to be, what? 1 plus 2x plus 1, x squared minus x, dx. So now, if I go ahead and take the derivative, if I separate this out, I'm going to get what? 1 plus x a plus x minus 1 b dx, because x and x minus 1 is this how this guy separates out. So now I have to solve for a and b such that I end up with 2x plus 1. Okay? So let's go ahead and do that. Put it up here. I'm going to get ax minus 1 plus bx over x minus 1. And this needs to be equal to, right here, 2x plus 1, x minus 1.
It says to solve it without using partial fractions.
Without using partial fractions?
Yeah.
Without using the technique of partial fractions. Oh, okay. Well, not only that, this here is negative. Okay. This makes more sense, because I was going to talk about this anyway, so this is good. All right, so let's go ahead and restart the program. We have here, okay? We have here, and we got down to here. Okay, so we're going to solve this without partial fractions. And the way to do this is by substitution. So if I substitute, let's go ahead and make this 2x minus 1, x squared minus x dx. You have to be able to visualize the fact that if I substitute this guy as u, what is du? du is equal to 2x minus 1. Ding, 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 right there. Okay? So in other words, this guy here is du. So you end up with a situation where this is going to be x plus c plus 1 over u. That's this guy here, and this guy was du. In other words, you ended up with x plus c plus natural log of u, which was that guy. Right? So in one fell swoop, you just go ahead and get it through. Okay, so that was 21, 27, 27. Solve the initial value problem using the partial fractions, blah, 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 blah. Okay? So this is something that you want to pay close attention to because the test is tomorrow and there is a question that is very similar to this question. Okay? I don't know how much more obvious I could be at this point, but here we go. dp dt is equal to 0.006 p 200 minus p. And I'm also given that p is equal to 8, or p naught is equal to 8. In other words, when t is equal to 0, p is equal to 8. Okay? So let's go back and look at page 374. Page 374 states that when dp dt is equal to kpm minus p, my solution automatically is going to be p is equal to 1 over m, the carrying capacity, which should be there, correct? 1 plus a e to the negative kt, or mkt, I'm sorry, mkt. Okay? So what do we know here on this one right here? I know the m value. I also know the k value. Okay, so I actually don't have to really go ahead and go and solve this through. Right? I can go ahead and say, okay, I know that p is equal to 200, the carrying capacity. 1 plus a, I still do not know. I have to solve for that. M is 200 times 0.006 t. All right, so this is going to be equal to 200, 1 plus a e to the negative 1.2 t. You understand where the 1.2 negative 1.2 came from? This is m times k here, right? M times k, right there. Yeah. So how do I solve for a? I'm going to utilize this guy here. When t is equal to 0, p is equal to 8. So I get 8 is equal to 200, 1 plus a, t is equal to 0, so this guy becomes 1 right here. So this is what I get. So I get 1 plus a is equal to 200 divided by 8.
Plus
25. A must be 24. So your final equation is P is equal to 200 over 1 plus 24 e to the negative 1.2 t. Is that all that we're asking for? No, then use a graphing utility to generate a slope field. I leave that one up to you. You guys can do the slope field. Because I am not going to do that. 20.
I'm gonna have to do that on a
that was 27, and let's see if that's correct. Are we good? Yep, that's it. Okay, that's 27, and did I do 21? I did 21. Okay, we're all good. Okay, all right. So, briefly going over the test. 7.4 was what? 7.4 exponential decay and growth. So, I'll tell you right now, you are going to have a half-life problem, and you're going to have a Newton's law of cooling problem. Okay? So, make sure you know how to do the Newton's law of cooling and the half-life. Okay? There's also an additional question. I'll let you guys figure that one out. There's one lab. I can't tell you everything, right? So that's 7.4. 7.5 is the logistic growth. Like I said, something like this is going to be on the test. And there will be one more other question.
Wait, so it's only 5?
There's only 5 questions on the test. Okay? All right.